Welcome to Math 158. In contemporary society, we are confronted with quantitative issues at every turn. We are required to make choices about purchases, credit cards, savings plans, investments, borrowing money, who to vote for, and what headlines and news reports to believe. If we want to be informed citizens and savvy consumers, we must be quantitatively literate. At the heart of quantitative reasoning and literacy is critical thinking, which is necessary to deal intelligently with the information and misinformation that comes to us via television, computers, and newspapers. In this section, we will view with a critical eye conclusions based on averages. Example 1. The data below is adapted from the tables compiled by the U.S. Bureau of Labor Statistics and adjusted for inflation. Can we conclude that the wages within this time period increased, decreased, or stayed the same? Let's examine the table below. Notice that the total weekly earnings in the year 2000 is lower than the total weekly earnings in the year 2013. So the total weekly earnings did increase during that time period. However, the number of workers during that time period also increased. To really determine whether wages increased, we need to consider whether the average workers' wages increased. To get the average workers' wages in 2000, let's take the total weekly earnings and divide by the total number of workers. Note that both of these are in thousands of units. So we will have to add 3 zeros or multiply these numbers by 1,000 when we do the computation. When we divide, the result is an average weekly earnings of $819 per worker. Similarly, to find the average weekly earnings per worker in year 2013, let's look at the total weekly earnings in thousands and divide that by the number of workers in thousands. When we do so, we get a result of $827 per worker. Notice that this is higher than the average weekly earnings that we found in the year 2000. But before we conclude that wages increased for the average worker, let's dig a little deeper. We might note that workers without a bachelor's degree tend to make less than workers with a bachelor's degree. How has wages changed for the typical worker in each of these subcategories? To find the weekly earnings of a typical worker for each subcategory, let's once again take the total weekly earnings and divide by the number of workers. Pause the video here to complete the table by finding the average weekly earnings in each of the subcategories. Then determine whether wages increased or decreased within this time period for workers without a bachelor's degree and for workers with a bachelor's degree or higher. Check your answers to make sure they match mine. If not, rework the problems by dividing the total weekly earnings in thousands by the number of workers in thousands for each of the subcategories. Did you notice that for both workers with and without a bachelor's degree, wages decreased during this period? However, overall wages increased during this period. How is this possible? Notice that in the year 2000, workers without a bachelor's degree make up almost 69% of the workforce. While in the year 2013, workers without a bachelor's degree make up only about 61% of the workforce. Since workers without a bachelor's degree are typically paid lower wages than workers with a bachelor's degree, this change in demographics resulted in an overall increase in wages, even though the wages in each subcategory decreased. So, to answer our our opening question. Can we conclude that the wages within this time period increased, decreased, or stayed the same? The answer depends on your perspective. Overall, wages did increase, but from the point of view of the typical worker, with or without a bachelor's degree, wages decreased. This paradox is caused by the increase in the percentage of workers with bachelor's degrees, as workers in this subcategory tend to make more money. The phenomenon in which combining or aggregating data masks underlying patterns is called Simpson's paradox. Often this occurs when a factor distorts the overall picture, but this distortion goes away when the underlying data are examined. The article above shows another real-life example of Simpson's paradox, in which separating wages by the level of educational attainment of the worker may show that over a period of time, wages at each level decline. But if the proportion of better educated workers increases over that period, wages may increase overall. Such results can be counterintuitive. Without careful consideration, one can be led to an incorrect conclusion.